All right, so we're fixing to start 1.6, which is inverse functions. And then we're looking at covering 1.7 tomorrow. We've already talked about even and odd functions, so I'll put a little reminder up there for you in just a sec. And then Wednesday, we'll do a review for the test, okay? And we'll test Thursday and Friday. All right?
Section boards.
So, is it? No.
I was like, is Roy learning it one day?
Yeah, no, it's not.
Is that for the person with a degree, or is that just for anybody?
For anybody, it's not
Like
everyone.
for
Okay, so listen, let's talk about even and odd functions for just 1 second, because I'm not going to go back and reteach this, but it was not on the last test, so I popped it on this test. Okay, so remember, if f of x is equal to f of negative x, what do you know?
Even.
Yeah, that makes an even function. Okay, and if f of negative x is equal to the opposite of f of x, then this makes it an odd function. Okay, so remember that? We did that last week or something. So that will be on this test. I think there are some on the review. Normally I don't, yeah, I'm going to give you a review. First 6 weeks, first semester, I didn't really give reviews for my test. I just, gave worksheets as we went along. This semester, I made some reviews. Some of the kids bugged me a few years ago about, hey, Miss Davis, could we just do some reviews? And so I made some, and they kind of took the place of some worksheets and everything. So instead of grading like 5 worksheets as we go through there, I just gave you a review. So that means we're not going to have as many worksheets and things, daily grades, as we usually have. I know a lot of times we'll have anywhere from 7 to 9 daily grades, and I drop your lowest. We may only have 5 or 6.
Are you still dropping that
Okay.
lowest? Because I need.
Yes, I'm still
Okay,
dropping
good.
your lowest, okay? When I say 5, because how many do I legally have to give you?
4,
6,
6.
okay? But I give you a free 100, so that is counted as 1, okay? So every 6 weeks I give you that one, and then, so that makes me only have to do 5, all right? So here we go. Are you ready? We're gonna talk about inverse functions, 1.6. First thing you need to know, very, very important. In order for a function to have an inverse function, it must be 1-to-1. Okay, so in order for a function to have an inverse function, it has to be a 1-to-1 function. So, what do we need to define?
1-to-1.
1-to-1, very good. So let's talk about what a 1-to-1 function is. You're going to remember a lot of this from Algebra 2, okay? Exactly right. So a 1-to-1 function,
Y, there's 1 X.
that's exactly right.
No,
So, y'all listen to me. Let me ask you this question first. If it is not a function, could it be a 1-to-1 function?
No.
People, that's the craziest thing I've ever heard of in my life, okay? If it's not a function, it obviously can't be a 1-to-1. This is a very specific function. Pardon me, yeah. All right, so, yes, 1-to-1 function. So, like Colton said, every x has exactly 1 y. That's what makes it a function, right? And every what?
Y.
Good. Every y exactly 1x. Alright, that's what a one-to-one function is. It kind of goes both ways. Alright, so what if I had a list of points? Okay, what if I had a list of points? What would I be looking for to see if it was a one-to-one function?
You look at the x's, make sure those are all different, and you look at the y's, make sure those are all different.
Okay, so the x's and the y's can't what?
Be the same.
What word do we use?
Repeat.
Thank you. Can't repeat, very good. Okay, what if I'm looking at a graph?
Has to pass the vertical line test.
Both
Both
vertical and horizontal.
Like both vertical line tests, like what's that? One's with a pencil, one's with a porcupine quill. No, it has to pass the vertical and the horizontal line test.
So no parabolas?
Oh, that's something really to think about. No parabola. He
Oh,
won't,
they got two y's.
yes,
Or, I mean, if it's horizontal, it's got two.
yes.
X.
He won't pass the horizontal line test. All right, one more thing we need to learn before we get started, okay? F to the minus 1 of x, sorry. F to the minus 1 of x. This means F inverse of x. Okay, it is the inverse f of x. Alright, so just a little terminology that you're gonna see and that I want you to use, okay? Because if you don't use this right here, you're not saying that it's the inverse. Alright, you're just saying, because of the way we're gonna do it. Alright, anybody got a question so far?
Wait, so is the negative in front of the,
I'm sorry, I didn't write it very well, I don't know what happened.
that's not a negative? Okay.
That's what it looks like. This is not a negative, this is my little,
Dash.
yeah, point maker, or whatever you call those things. When you make those, what is that called?
Arrow.
Bullet.
Oh.
I can't say that at school. So, everybody got it? Okay, so what I'm gonna do down here is I'm gonna make two different charts. Okay, my first chart is gonna tell you how to find, very specific steps, how to find an inverse, okay? And then my second chart is gonna tell you how to prove that they are inverses algebraically, because that's the way we're gonna prove it, okay? So, here's the first little chart. He is going to be to find an inverse. Okay, so these are the steps to find an inverse. There are 4 steps. 4 steps. One thing I'm gonna be kind of snarky about, all right? So I'll write that in pink and be sure and tell you what it is over here. So number 1, you are going to change the f of x to a y. Okay, it sounds like something silly. Why do I have to do that? Well, because if I tried to tell kids, switch the x's and the f of x's and then solve for they would be like, what? What is she talking about? All right, so we're just gonna change it to a y. All right, and then the second thing you're gonna do is you're gonna switch the x's and the y's. That's what creates an inverse, guys. When you switch the x's and the y's, that makes an inverse function. This is where I'm going to be a little snarky. This thing right here, don't just keep writing it. When I switched the x's and the y's, did I change the whole problem?
No.
Yes. So don't keep writing it down the page. This you're going to put to the side. Okay, you're going to put it to the side. You're not going to put it underneath. And I mean, I'll show you, and you'll understand, okay? But when you put it underneath, then if a person's looking at your paper, they think that you're just working a problem down the paper. okay? And they're like going, whoa, wait, what happened all of a sudden? And, so we're not gonna do that. All right, the third thing you're gonna do is you're gonna solve for y. And the last thing you're gonna do is you're gonna change the y to a f inverse of x to show that he is an inverse function. Now, does that seem difficult? No, okay? This is not difficult.
Are you going to make it? Yes.
No, we're not going to. We're not gonna make it really, really hard. So the other chart over here, we are going to prove, show, justify, verify, whatever word you wanna use, okay? All those words mean the same thing. Algebraically, okay? Cause later on today, I'm gonna show you how you could look at two functions and see if they were inverses of each other, okay? But do we go by looks?
No.
No, okay, so we're not doing it that way, we're doing it algebraically. So, prove algebraically they are inverses. Now, in order to do this, you have to have a skill that we've already learned this year. It is an Algebra 2 skill, so you should have learned it last year. If you didn't learn it last year, you had 2 opportunities to learn it this year. So, if you don't know it, shame on you. So, here's what you're gonna have to do to prove or show, verify, justify, whatever. F inverse of x must be equal to F inverse of f of x okay, and they both should be equal to x. All right, so you're going to find f. These are composite functions. Okay, you're going to find f of f inverse, and it should be equal to x. And then you're going to find f inverse of f, and he should be equal to x also. Okay, now here's the other snarky little part. You must show, Sean, this is for you, every step. Okay? Or you will get no credit. Alright? And there's a reason for that, and when we get to it, I'll tell you what the reason is. Alright? Because the reason, it's gonna tell me if you really know what you're doing or not. Okay? I'm gonna see really fast, oh no, this child does not know what they're doing. Alright? People, we know what the answer is. So what happens is the kids just like slash, 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 slash. And then they're like, X. And I'm like, no, I'm not doing that. Okay? There's an order that they have to be done in. And so you are going to have to show me that order. Alright, so are you ready?
Are these problems like gonna take a lot of space?
No. No, we don't. So this is example 2. We're gonna do this one together, okay? We are going to find the inverse function.
Thank you.
Blessing.
Thank you.
Sorry, I had to write something on it. We're going to find the inverse function and we're going to show algebraically that it is an inverse. So basically, we're just doing those 2 charts. You agree? You with me? Okay, so I'm going to give you the function. F of x is equal to x minus 6. All right? That's my function. So first thing we're going to do is we're going to show that it's we're going to find its inverse. What did I tell you was the first thing you need to check?
It has exactly one Y. No, I don't know. 1 to 1.
1 to 1. Y'all, before you even start, every time you need to check and see if that thing is 1 to 1. Okay? Do you think I'm going to test you on that on the test? Okay? So, if it's not 1 to 1, you just write what? Doesn't have an inverse function, and you're done. Alright? Or you spend 10 minutes trying to find it and miss the problem. Alright, so what does this look like? Y'all, the easiest way to check and see if it's 1 to 1, yeah, plug that thing in the calculator,
It is.
okay? And then look at its graph. What does this look like when you graph it? Yeah, he's just a line like this. Is he 1 to 1? Yes, he is 1 to 1. Okay, so I know he's 1, 2, 1. I checked that, okay? I need to make sure I check that. All right, so now I'm going to start and I'm going to find his inverse. What was the first thing it told you to do?
Change f of x to y.
Okay, so y is equal to x minus 6. Everybody with me? Okay, what was the next thing that it said to do?
Switch the x's to y.
Okay, so do you understand why I don't want you to do that under here and then keep working down the paper? Because then it's like you said this and this are the same thing. They're not. So just go out here to the side and start a new column. All right, switch your x's and your y's. So it's going to look like this. X is equal to y minus 6. Do y'all understand why? Okay, so if somebody's looking at my notes and stuff, they're not like, wow, wait, what'd she do? What happened? Okay, now what does it say to do?
Solve for y.
Solve for y. So tell me what to do. Add 6 to both sides. So I have y is equal to x plus 6. That's my inverse function. How do I show someone that it's an inverse function? I replace that y with a f inverse of x, okay? Because then, right now, I look at it and I go, oh, okay, well, I don't know what that means, all right? But now I'm going to rewrite it as f inverse of x is equal to x plus 6. So now I look at these two functions and I say, oh, here's the function and here is its inverse. Do you understand? Okay, so this is my first answer. You with me? All right, now we're going to verify that those things are inverses, and we're going to do it algebraically, okay? So, the first thing I'm going to find is I'm going to find f of f inverse of x, okay? And then I'm going to find f inverse of f of x. Now, what should they both be equal to?
X.
X, okay? People know what they're supposed to be equal to. If they're not equal to x, either you made a mistake here, or you made a mistake finding the inverse function.
Or was it 1 to 1?
No, that's not always gonna tell you, because here's the thing. I'm asking you to find out inverse function, okay? He does have an inverse, but it won't be a function. You see what I'm saying? All right, so let's do this one first. I'm following these directions. I'm going to say it another way, but that's not the way I taught it, so I'm not going to do it that way. But some of you like it like that. All I'm going to do is take the inverse function and put it in the original function. He's my input, okay? And then this other one, I'm going to take the original function and plug him in the inverse function. All right? So this guy right here, f of, what is the inverse function?
X plus 6.
So, now these are my directions, right? So he's telling you where to go. Go to the f function. Here is my f function. In place of this x, I'm putting x plus 6. What you do to one side, you do to the other. So over here on this side, everywhere there's an x, where are we going to plug in? X plus 6. So there's an x plus 6. And then what? Minus 6. What happens to positive 6 and negative 6? And what am I left with? Inverse functions will do and undo each other, okay? That's what happens with them, Alright, that's why you end up with an X, cause everything one does, the other one undoes. Alright, so over here, I'm going to the inverse function. And I'm going to put, what is f of x?
X minus 6.
X minus 6. So I am going to the inverse function. Here he is down here. In place of this x, do you see how if you don't know how to do a composite function, you're in trouble?
Yes.
Alright, so go into the inverse. In place of this x, I'm putting x minus 6. So there's an x. What am I putting?
X plus 6.
X what?
Minus
Minus 6. And then what?
plus 6.
Plus 6. People, listen to me. When I grade this right here, I'm grading your work. Okay? So if over here you have x plus 6 minus 6, what am I going to do? I'm going to count it wrong, people, because that's not what this says. Do you understand? It's important that you do it the right way. These two cancel each other out, and I'm left with an x. Anybody got a question? All right, so that's like a kindergarten problem, right? So let's start off with, let's do another one that's a little more difficult. So let's do example 3. Find, what does that mean?
Inverse function.
Yeah, the inverse of f of x, f inverse of x, and verify, okay, same thing as show, all right, verify algebraically that it is an inverse. Okay, is everybody okay so far? All right, so let's go find, oh, I have to give you the function, don't I? Let's say f of x is equal to 2x to the third minus 1. 2x to the third minus 1. So we could graph that function. Should you know exactly what that looks like? Y'all look, just to be safe, you could do it on your calculator. I'm not going to because I have a function saved in there that I don't want it retyped for my algebra kids. Okay? This is a cubic, right? You know what a cubic looks like? Like this? Y'all agree? All right. What does that 2 do to it?
Move it.
What is it? A vertical what?
It's on.
A vertical what? Stretch of 2. So he took this guy right here and he stretched him. The only thing he's well, these will go up and down faster, but this thing right here, he's gonna go up faster, come down faster. All right. What does this minus 1 do to it?
Move it down 1.
Moves it down 1. Okay. So he looks like this.
It's not
All right.
1 to 1, is it?
Does it what?
It's not 1 to 1.
It is.
Why?
Because it curves like, it's like a.
It doesn't go. Now listen to me.
Curves down,
Li-
right?
Okay, listen. No, it doesn't. It's ever increasing. Okay? He's doing this right here. He doesn't have any humps in him. Why does he not have humps? Because y'all, he's missing all that jump. All that x to the second, x to the first, and all that stuff. Okay? That's the stuff that makes those humps in there. All right? He doesn't have any of those. The only place that you might even consider that he might not be 1 to 1 is right in here. But guys, listen to me. In order for him not to be 1 to 1, that would have to go straight across. Do you agree? This is a curve. Are there any parts of a curve that are straight? No, that's a line. All right? So he is 1 to 1. Okay? He is 1 to 1. All right? So let's find his inverse. All right? Tell me what to do.
Y equals 2x to the third minus 1.
Okay. Y equals 2x to the third minus 1. Now what are we going to do? Switch the x's and the y's. Where am I going to put it?
Side.
Go to the side. Do not put it underneath, people. I'm being serious about that. Every time you just don't follow what I like, I'm going to take points away from you. Okay? So, x is equal to 2y to the third minus 1. Now I'm solving for y. So what do? Add 1. Are y'all with me? x plus 1 is equal to 2y to the third. Can I take the cube root yet?
No.
No. You cannot take the cube root unless what is cubed is all by itself. What's over there that I need to get rid of?
2.
Okay. So I'll divide by 2. I'll just leave it like that, okay? Don't write it as a fraction and all that mess. Okay, so now he looks like this, right? Y to the third is equal to x plus 1 over 2. You with me? Ask me questions if you got a question. Now what do? Cube root. Okay, here's something right here. If you write that cube root like this, I'm going to count it points off. If you write it like this, I'm going to count points off. Where does it go? It goes in that little V right there, people. Okay, this is what I want. All right? So, yes, put it there. This just looks like, I don't know, some of you are just sloppy, but then I wonder, do you really know where that goes? Do you know what you're doing? When I see it written up here, I'm like, what in the world? Does that person know what that is? That's an index number. He goes inside. Okay, he's not an X-desk member. I made that word up, sorry. All right, he's not outside. He's inside that little V, all right? So, cube root both sides. This takes care of this power. And this one, I like my answer just like this. Okay? We're just gonna leave it just like this. Now, what do I do with it?
Put the F.
Yeah, F inverse of x is equal to the cube root of x plus 1 over 2. This is my answer.
And
Now I have to verify.
wait, can we write that under, or do we have to write that to the side?
You can write it under. Okay, so how do I verify? Well, I'm gonna find f of f inverse of x, and I'm gonna find f inverse of f of x. Now, this is where you're going to see that the order that you do things in is going to be either cost you points or you're gonna be okay. Because you cannot just do this stuff in any order that you want to. You can't just start slashing mess and then go X. Okay, so let's do this guy. So I'm doing the F function. I'm gonna replace the inverse function in for F of inverse. F inverse, right there. So F of the cube root of x plus 1 over 2. Are you with me? All right, now listen to me. Remember what the object of the game is. The object of the game is to work ahead, not to copy my notes, okay? But to work ahead of me, because that's when you know what you're doing and where you learn where your mistakes are, okay? So I'm going to the F function. Here's the F function right here. In place of x, I'm putting this, okay? So I got 2, so I write 2 down. Uh-oh, there's an x, so I gotta put this guy. The cube root of x plus 1 over 2, and then I have to cube it. And then he goes minus 1. Anybody got a question? Everybody okay? All right, so what's the first thing that happens?
Cube root takes away the cube.
Yes, these cubes and this cube root, they do away with each other. And you're left with 2 times x plus 1 over 2 minus 1. Can I slash my plus 1 and minus 1 now? No, you cannot, guys. Okay, what do you have to slash now? Your 2's. So then you're left with x plus 1 minus 1, and now who slashes? Yeah, plus 1 minus 1. And what is it equal to? Okay, so like when I first started teaching this is what kids did. They took this problem right here, and they slashed, slash the ones slash the twos and then wrote X down. And I was like, what? What? Like, can I tell the order that you, I'm not running some kind of carbon testing on your paper to see what you did first, okay? So the only way that I can do it is to make you do it one step at a time to see what you're doing, all right? Make sure you know. Okay, so let's go over here. I'm doing F inverse of. So in here, I'm going to put this f of x function. 2x to the third minus 1. Okay, so now I'm going to the inverse function. Here he is. In place of my x, I'm putting this mess right here. So I go over here. I got the cube root. Uh-oh, there's an x. What am I supposed to write? 2x to the third minus 1. So 2x to the third minus 1. Now what else goes on the top? Plus 1. All over 2.
So then do you do the twos first?
Oh, can you do the 2's right now?
No.
Why?
You got.
Because you're not taking them out of these guys right here. Do you see what I'm saying? You cannot do the 2's right here, guys. What do you have to cancel out first? No, the 1.
Why the ones?
Because that, look, you can't take the 2, you can't divide that 2 out unless you can take it out of everybody on the top. And you're not doing that, okay? So, take those 1's out. Now I'm left with the cube root of 2x to the third over 2. Now can I take the 2's out?
Yeah.
Okay, yeah.
Why don't you do the 3's first?
You can't do the 3 unless what's raised to the third power is all by itself. The same way that you can't take a cube root until that's all by itself, okay? So now these 2's are gone. So now I'm left with the cube root of x to the third. Y'all, if you tried to do the 2's now, you'd be saying, what's the cube root of 2? 1 point something, but nobody knows, okay? So you can't do that. So now I'm stuck with this guy. Now what happens? What's the cube root of x to the third?
X.
Here's my x. All right, anybody got a question? No? Everybody good? Now that's not bad, is it? Okay, but now listen to me. Y'all, you gotta do this stuff in the right order, okay? You wanna know which order that you do it in? You are undoing something. So it's PEMDAS what? Backwards. Okay? It's like untying your shoes. Add and subtract first. Then you multiply and divide. And then you do your exponents. Okay? It's like if you tried to untie your shoe and you tried to do that little tie thing, untie the tie thing first before you did the bows. That's not gonna work. Okay? That won't work. Alright. Now, before we move on, I want to do one thing. Alright, so I'm going to take me a little graph. I'm going to show you what an inverse function looks like on a graph, okay? I don't have my stuff out here, so my notes out here, so I've already done this on the first half of it, so I'm tearing that off.
We're turning our paper.
All right, so here we go. I'm gonna do the function that we just did, okay? So I'm gonna draw me, I'm showing you what it looks like on a graph. Now remember what I told you. We don't go by looks, okay, because they can be deceiving. You know, we all know those people that look really nice and are mean as snakes, okay? So, so I want us to, but I do want you to know, it's a good show of what happens, and sometimes it's a quick check. All right, so I'm going to do the one we just did. F of x is equal to 2x to the third minus 1. All right, F inverse of x was equal to the cube root of x plus 1 over 2. Do y'all see those inverse things happening?
Yeah.
They subtracted 1, what did they do?
They added.
They multiplied by 2, what did they do? They raised to the third power, what did they do? It is literally the opposite, guys.
Like,
Okay.
find the equations of, like, you can do that, right? By just looking at it?
No.
No, I wouldn't do that, no. I mean, when Sean says no, then you should say no too, all right? So, so the first thing I'm gonna do is I'm gonna graph this guy right here. Are you with me? I'm gonna make a little T-chart. All right, and I'm gonna pick specific points just because this thing's gonna get tall really fast and he's gonna go down here really fast. Do you agree? Because of that 2. So I'm just gonna pick -1, 0, and 1. All right, so this is 2 times -1 to the third minus 1. What's -1 to the third?
-1,
What's -1 times 2?
-2,
And -2 minus 1?
-3.
So at -1, he's -3. All right? What about 0? What's 0 to the third?
-1,
0 times 2 is
0,
0 minus 1 is
-1.
-1. Now that's what we talked about earlier, right? We talked about that -1, shifting that thing down 1, right? So let's look at this guy. He's gonna be 2 times 1 to the third minus 1. What's 1 to the third? And 1 times 2 is, and 2 minus 1 is, so at 1, he's 1. All right, so this is what he looks like. And he gets steep really fast, because like at the point 2, it's 15. It's way, way up there. Okay, so that's why I only did a few. All right, so I'm going to write these points by here. This is -1, -3. This is 0, -1. And this is the point 1, 1. Okay, now let's pretend that we just took any point in the world. Any point on this graph, and I called it AB. Okay, how would I find the points on this graph right here? That's exactly right. Y'all, what did you do? You switched the X's and the Y's. So if this AB were on this green graph, he would be what? BA, right? Yep, same signs. No, we didn't change any signs or anything like that. What would this point be? -3, -1. What would this point be? -1, 0. What would this guy be? 1, 1. You couldn't miss him. All right. What about that AB? What's he going to be? BA. So let's graph these points and I'll show you what he looks like. So -3, -1. That's this point right here. Okay. He is -3, -1. 0, 1 becomes what? 0, -1 becomes what? -1, 0. All right, and this guy stays the same. Okay, and this is what your graph looks like. Okay, now think about this. This is an inverse function. So while this guy kind of snakes around the y-axis, this guy snakes around the x-axis. Do you see that? Do you see that this kind of looks like a square root function? But because I have an odd root, you'll have negatives in there. See, an even root, you don't have any negatives, right? But an odd root does, so it goes down like this, all right? Now, I'm going to show you this, okay? But remember, I drew this and I'm not an artist, okay? But this is the line y equals x. What do you notice about those two graphs?
It's a reflection.
It's a reflection across this line right here. If I folded it on here, this blue part right here would end up over here. So this point would be like here, BA, okay? This piece lands up there, this is up there, and that's down here. You see it?
No.
No? Watch. You see if I fold it like this, you see how this green piece ends up being that blue piece? Okay? And this little hump thing ends up on this hump. And then this blue ends up reflecting across there. Because this axis is going on that axis. Okay? So, anytime you have an inverse function, he is going to be reflected across that y equals x line. So once you find some points on there, you just flip-flop those points, okay? And then graph the inverse really easy. All right? So just a picture of what an inverse function looks like on a graph. I think it's always cool to kind of look at that. If I were in a hurry, maybe taking a really stressed test and they didn't ask me to prove it algebraically, they just said, hey, are these inverses of each other? I might pop that thing in my calculator, okay? And, oh well, I'm just gonna go, I'm gonna change it for y'all, because I like y'all. All right, so I'm going to go ahead and put these in here, and I want to show you. Could I check my table? Yeah, some kids are like, oh yeah, you can check your table, that's really easy. Not so easy, okay? So I'm going to show you why. So y is equal to 2x raised to the third minus 1. And then my second one is, do y'all know how to put cube roots in here?
Yes.
Okay, so it's the way you say it. So cube, that's a 3. If you press the math button, number 5 gives you any root. So I'll choose number 5 and he pops it in there as an index number. I want a fraction button now. So x plus 1 and then over 2. Okay, so I'm going to go zoom 6. And there's my graph, okay? So, now he looks a little wacky, but if you put it on a square graph, it would look a lot better, okay? Is the bell fixing to ring on me?
Yes.
Oh, I got 5 minutes. No, it's
3
not.
minutes.
3? Dang. Okay, so look at the table. Second and table, okay? Second and table. So, look at the ones all the way across. I like that, okay? But, okay, what about 2 and 15? Could I check that one? Yes, can I check 2 and 15? You just go down. Would you want to be checking these guys? Do you see these ugly numbers? So I'm going to go down here and check, what should it be? 15 what? 2. He's going to be way over here, guys. He's not going to be right here. You see what I'm saying? Okay, so you got to learn how to read a table. All right, what else? I got one more problem. Example 7. Find the inverse and verify algebraically. F of x is equal to 5 minus 3x all over 2. 5 minus 3x all over 2. So I'll let you get started on that. I still got like 4 minutes.
No, you
Y'all
don't.
let the bell ring.
You have 2.
Oh, okay.
You're like multiplying everything by 2.
Yeah, that, y'all look. The first thing you gotta do is this, right? And then when I switch the x's and the y's, some kids have a problem with this. If you wanna solve for y, who do we need to get rid of first? Yeah, you need to get rid of that 2. Go ahead and multiply both sides by 2. Alright, then I'm going to subtract 5 from both sides. So I'll have 2x minus 5 is equal to negative 3y. And then I'm going to divide by negative 3. Now watch this. Pay attention. Y is equal to, sorry, I don't want you to leave that negative down there. So what do?
Change all the signs.
Yeah, pull it up top and pull it through the whole entire top. So this becomes what? Negative 2x and positive 5. Alright, and that is my inverse. And I'll let you prove it algebraically. And I'll pop it up here on the screen tomorrow.